Welcome to this video tutorial. In this video tutorials we will touch some of the things that we have learned during the different units of statistics too. So I recommend you to pause the video and read carefully the statement, and then after that I will develop the solution. In this case, we have to compute a confidence interval for the difference between population means, where in this case we know both variants from the population A and population B. We have information that these populations are normal. In the first case is a normal with expected value mu, we don't know, and standard deviation 1500. We have a sample of 100 citizens, and the mean of this random variable is equal to 35,600. In the case of the second population, is also a normal with expected value mu, we don't know the expected value, and the standard deviation is equal to 800. We take a sample of 36 citizens, and the sample mean is equal to 32,400. So we are interested in computing a confidence interval of 0.95 for the difference between population means. As we know, both sample means are going to be distributed as normal because the population is normal, and the difference between these two normals is going to be also a normal distribution with expected value, the difference of the expected value mu sub A less mu sub B, and the standard deviation, the square root of the variance of the difference. As you know, the variance of the difference is equal to the sum of the variance less 2 times the covariance, but as our samples are independent in one city from the other, the covariance is going to be 0, so the standard deviation will be the square root of the sum of the variances of these distributions. So if you compute with the numbers that we have, you will reach to a normal distribution that is, we don't know where it is centered, but the standard deviation will be 200.69. So we build the confidence interval in the same way than in previous cases. Is centered in the point estimator, in the case that the differences between means less the point that led in a normal 0, 1, a probability of alpha divided by 2 in the left side, multiplied by the standard deviation of the distribution, and in the upper side will be the point estimator, in this case the difference between means, plus the point in a normal 0, 1 that led to the right side, alpha divided by 2 probability, multiplied by the standard deviation of the distribution. You know that is the square root of the sum of variances. So we want that the confidence interval has a probability of 0.95. So we have all the information in order to substitute. The difference between sample means is equal to 3,200 less the point in a normal 0, 1 that led a probability of 0.025 is minus 1.96 multiplied by the standard deviation 269, and in the other side of the interval is the difference between means 3,200 plus the point in a normal 0, 1 that led a probability to the right side of 0.025, that is 1.96 multiplied by the standard deviation 200.69. So if we let a probability of 0.025 in the lower side and in the upper side 0.025, this is because in the middle we have a 0.95. So the final result is that we can guarantee that we have a difference between the means with a probability of 95%. This difference will be between 2806.64 and 3593.35.